Video tutorial looks at the mathematical strand of linear and non-linear relationships, and more specifically we're going to focus our understanding on solving equations. So the first thing you need to understand is, well, how do you solve an equation? There are two methods to solving an equation. So in both methods you need to make sure that the variable, or the unknown, in this particular case x, is on one side of the equal sign, while the numbers are on the other side of the equal sign. So you can see that we've started off with this equation and we've now calculated to get it to this. And we'll go through more of an explanation on how to do that. So there are two methods that you can use, and I'm going to go through both methods with you. Both of them get you the answer, but it's really up to you which one you would like to use. So the first one we're going to look at is method 1. So using method 1, we need to use the inverse operations. Okay, so that means the opposite. So inverse is the opposite. So I mean, if you had plus 4, the inverse would be minus 4. If you had negative 5, the inverse would be plus 5. If you had divide by 3, the inverse is multiplied by 3, and if you had multiply by 6, the inverse would be divide by 6. So essentially, it is the opposite of what is happening. So, and essentially you use these in order to get x by itself or to solve the equation. So it's important that you maintain balance. That means whatever you do to one side, you must do to the other. And an example of this is, here we have x plus 4 equals 6. Now the inverse of x plus 4 is x take 4, or just take 4. But we need to do that to both sides. And if we do the inverse to both sides, positive 4 take 4 leaves 0, so therefore we're just left with x, and 6 takes 4 is 2, so therefore we've solved our equation, x equals 2. Now with method 2, okay, we still use the inverse of it, but we only do that when we move it to the other side. So 3x, for example, is 3 times x. Okay, that's going to equal 12. But what I can do is I can get this 3 times and I can move it to the other side. And when I do that, it becomes divide, so it becomes the inverse. Okay, so that's now no longer, so the 3 times x is no longer there. We're just left with x on our left-hand side. On our right-hand side of the equation, we have 12 divided by 3, which is 4. So remember, with method 2, when you move something or move a term to the other side of the equal sign, right, you must then change it to its inverse operation. So we're going to have a look at a few equations now. Now these are very simple equations. They are one-step equations. That means that you only need to do one thing in order to solve them. I'm going to do method 1 on the left-hand side and method 2 on the right-hand side. You'll then be able to see the difference between them and work out which one suits you. Now, let's work out all the method 1 equations. So remember, we're using the inverse and we're maintaining balance. So the inverse of negative 2 is plus 2. We need to do that to both sides. Therefore, these cancel out and x equals 8. On our next equation, remember this is 4 times x. So the inverse of timesing by 4 is dividing by 4. If I do that on both sides, the 4's cancel. I end up with x equaling 8 divided by 4, which is 2. Here, this is actually x divided by 2. The inverse is actually multiplying by 2. I need to do that to both sides. X, therefore, equals 12. If I'm going to do method 2, right, remember that I'm taking this negative 2, I'm putting it over the other side. This becomes plus 2. Therefore, x equals 8. Remember, I'm taking the times 4 and I'm moving it over here. It becomes divide by 4. So remember, I change sides, change the signs. X equals 2. Here, this is actually divided by 2. So if I move it over here, it becomes times by 2. X equals 12. You can see I get the same answers doing both. One of them we're using the inverse and maintaining balance. The other one we're using the inverse, but we're switching its side. Okay, so we're going to go through some two-step equations now. Now these are two-step equations because they involve two steps in solving them. So again, method 1 and method 2. So remember in method 1 we're using the inverse operations, but we're maintaining balance. So I've got 2x take 2, the inverse of take 2 is plus 2, that leaves me with 2x equaling 8. 2x is actually 2 times x, so the inverse is divided by 2. Therefore, x is going to equal 4. In my second example, the first thing, this is actually divide by 2, so I need to do the inverse of that, which is times by 2 to both sides. See if I can write a little bit neater. Times 2 times 2. That leaves me with x take 1 equaling 12. Now the inverse of take 1 is plus 1, plus 1. X therefore equals 13. Now I'll do it with method 2. The negative 2 comes across, becomes a plus 2. That leaves me with 2x equaling 8. This 2, which is multiplied by 2, becomes over and becomes divided by 2. X therefore equals 4. This 2, which is a divide by 2, comes over and becomes times 2. So I end up with x take 1 equals 12. This negative 1 comes over and becomes a plus 1. X therefore equals 13. Okay, sometimes we're going to have to solve equations with repeated variables. So the first thing you need to do is you need to be able to collect the variables or collect the like terms and simplify the equation, and then you simply solve it as before. So, as an example, here's a 5x minus a 4x. 5x minus 4x is simply 1x, or just x. Plus 3 take 4 is actually minus 1. And we know all of this equals 4. So, if we rewrite this in black, we've got x now minus 1 equals 4. Whichever method you want to solve it, you can either go inverse plus 1, x equals 5, or you can carry the minus 1 over here, it becomes plus 1, x equals 5. So the first thing you need to do is simply collect the like terms, simplify the the equation, and then solve it as you would normally. Okay, so here are some practice questions I would like you to have a go at. Please feel free to pause the video. Once you think you've got the questions correct, continue the video and we'll go through the answers. Okay, so let's see how you went. In our first question, okay, I'll do method 1 and method 2 for each question. Method 1, x take 5 equals 10. You could simply add 5 to both sides and you would get x equals 15. Or you could move the negative 5 over and end up with plus 5 and x would equal 15. For our B question, you could add 2, or the inverse of negative 2, so add 2 to both sides, you'd end up with 3x equals 12. Then you would divide by 3 to both sides using the inverse and you'd get x equals 4. Or you could move the minus 2 over and become plus 2, and you end up with 3x equals 12. You could move the 3 over and it becomes divide by 3, and you would end up with x equals 4. For question C, you could multiply both sides by 3, and then you'd end up with x plus 4 equals 24. Then you would take 4 from both sides, and you would end up with x equals 20. Or you could move the 3 across, and it would become times by 3, so the inverse. You could move the plus 4 across, which would become minus 4, and you would get x equals 20. Now in question D, you would essentially collect the like terms. 5x and 2x would make 7x. You'd go negative 2, and negative 2 is negative 4. equals 10. Then you could solve it however which way you wanted. You could go plus 4, 7x equals 14, divide by 7, divide by 7, x equals 2. Or, if you had 7x take 4 equals 10, you could move the negative 4, and that would become plus 4. You'd end up with 7x equals 14. You could move the 7 and become divide by 7, x would equal 2.